So welcome back. This is Joel, and in this video we will look into Stealthwatch, right? So I got a couple of requests from folks telling me they would want to try out Stealthwatch on EVNG, and I thought I'd make a couple of videos to show you how you can set it up, how you can bootstrap the configs, and look at some very basic functionalities, and probably you can improve on that and probably define more complicated labs, right? Cool. So that being said, let's do a little bit of theory to understand Stealthwatch, right? It's a very niche product from Cisco, right? So yeah. So when we talk about Stealthwatch, let's actually go back in history a little bit, right? So let me grab my pen. Okay, so if you look at the initial days, right, you used to have a laptop here, and probably there's a switch connected, maybe like an access switch A1, right, and let's imagine that is connected outside to the internet, right? Now where are our threats? Our threats are over here, right? So there are attackers sitting down here waiting to take advantage, waiting to enter the network in this fashion. So how do you protect your network? One of the most common approach is dumping a firewall here, right? So you put a firewall over here, and firewall in the initial days, the firewalls used to be stateless, right? Which is basically, so firewall, if you look at it in a simplest way, it's nothing but an ACL, right? So and obviously over the years, there has been advancements. They have added application visibility, application based controls, layer 3, layer 4, layer 7 and stuff like that. But in its simplest term, right, firewall is nothing but a layer 3 ACL. So you're basically allowing what has to go in this direction, what has to come in this direction. Now in the initial days it was stateless, which means you had to define both of these directions. You had to tell what traffic has to be allowed from inside to outside, at the same time from outside to inside. But as advancements happened, they kind of came up with what we call a stateless firewall, right? So in stateless firewall, you no longer had to define just get rid of that. Yeah, in stateless firewall you did not have to kind of like you had to just define the one direction, which is basically from inside to outside, and it was any traffic which is basically allowed, right, from inside to outside, because of the statefulness, the corresponding traffic was allowed in the inside direction, right? Now you can see because of this, again, there is still, you still have your risk of attacker somehow getting into your network, right? You probably have initiated a request outside to a legitimate website, but maybe the attacker has taken control of the legitimate website, and he or she might try to attack your network, right? So that was basically your firewalls, right? And obviously we still use firewalls. We use ASAs, we have firepower and stuff like that, right, from a simple firewalling perspective. The other perimeter security is basically your which is that your IPS, right? NG IPS, if you remember, next generation IPS coming from firepower. And there are lot of other vendors out there who also provide IPS, like Palo Alto, Checkpoint, and a lot of other vendors out, Zscaler, right? So IPS is basically again an intrusion prevention system. You can put it inline, or you can probably put it somewhere else and just send the traffic to that guy and do some kind of analytics over there. The main problem again with IPS is encryption, right? So if you look at the statistics, off late, the number of attacks, close to 70% of attacks are encrypted, right? So when a traffic is coming from, let me just get rid of this red one here, it's a bit confusing. Yeah. So when you have traffic flowing around, right, probably let's say this attacker is now trying to come inside your network. Most of the time this traffic is encrypted, right? It is encrypted. So when it is encrypted, if you don't have a very powerful IPS, or if you don't have a advanced IPS, this guy will not be able to do anything because the traffic is encrypted, right? IPS will not be able to understand what to do, or basically will not be able to categorize that traffic to be malicious, right? So in that case, your IPS also doesn't kind of hold good. Now, if you again go a little more deeper over there, you will basically find your latest NJ-IPS, right? Or basically, let's call it as your firepower, right? Now, firepower especially has this feature where it can do what we call as decryption as well, right? So it can do decryption, right? And then it can add some policies, or it can run some policies on it, right? Which means how it basically works is, imagine you're trying to access some HTTPS, right? Website or web server which is somewhere sitting outside in the internet, right? So when you're trying to access it, this NJ-IPS will basically act as think of it as a proxy, right? So it will break the SSL connection right over here, and it will act as a proxy and then send the traffic outside, and similar in the reverse direction as well. So your NJ-IPS is kind of able to see every single traffic in plain text over here, right? Because it is whatever traffic is coming from the client, it will break the SSL, right? And then it will look at the packet and then kind of create a new packet, right? Or create a new SSL session with the actual web server, and that's how it works. But then if you see, the problem here is that your NJ-IPS needs to have enormous amount of CPU, right? There's going to be a super huge amount of load on your NJ-IPS if you use it in this fashion. I mean, I would say use it. I mean, there are a lot of customers who do use this feature, which is SSL decryption and stuff like that, but they probably would do it on a very, very small subset of traffic, not 100% of their traffic, right? So something like that. But like I said, yeah, this is not again a very it's not again a foolproof process, mainly because of the limitations associated with respect to resources. You really can't tunnel all the traffic from your enterprise into one small NJ-IPS box and expect it to do everything for you, right? So there are a lot of such, let's say this has we can call this as kind of like a history, right, of how the firewalls, how the IPS have progressed, over time. Now, the other important thing which I also want to call out here is security is very multifaceted, right? Which means there is no one single approach which is correct or wrong, right? And I wouldn't say just having Stealthwatch in your system is sufficient. No, you would still need a firewall. You would still need probably an ASA or a firepower, and you would need an IPS. You would need umbrella. So security is a multifaceted, which means it's a layered approach, right? So you really need to have multiple layers, right, of defense against the threats outside, which are there outside in the internet, right? So where does your Stealthwatch actually come in? So Stealthwatch, in a very similar fashion, where does it come in? Let me just get rid of this. Yeah. So I would still put my firepower here, right? Let's still put the firepower, or a ASA, whatever it is, right? Whichever you're comfortable and whichever is meeting your requirements. But then, so you have an access layer switch here, and you have the, say, firepower over here, right? And this is your host or the client which is connected in your network. So I would probably do something like this, right? So like I said, Stealthwatch or a firepower individually is not, you can't use something, you can't just use firepower, you can't just use Stealthwatch, you need to use them in tandem, right? So I would basically go and configure my Stealthwatch over here, right? And I'll explain what Stealthwatch does, but think of it this way. So Stealthwatch, once you put here, what I could do is, the traffic which basically flows around inside my network and in both the directions, right? This is outside, there is a guy in the internet, I'm talking to him, probably a web server or a database, whatever it is, right? So what I can do now is, I can put Stealthwatch, I can probably kind of put it inside my network, and I can basically export, or basically Stealthwatch works mainly with NetFlow, right? So NetFlow, think of it as some part of your packet, right? So there are data packets flowing around. I wouldn't want to send the whole data packets to Stealthwatch, because that would kind of create a lot of other issues like privacy and all of that, right? You really don't want, imagine you're in a banking institution or financial institutions, you really can't send all the packets somewhere, to another place, right? So in such a case, I can probably use something like a NetFlow, right, which basically sends some of the most important let's call it metadata, right? Like basically your source IP, destination IP, source port, destination port, protocol. So the 5 tuple, right? So it sends that information up to Stealthwatch, and then Stealthwatch basically uses this information, uses the NetFlow information which is sent, right? And it basically does some analytics on top of it to tell you if a particular flow is malicious or not, right? So that's literally Stealthwatch, in simple terms, right? And I really don't care in this case. I really don't care if it is encrypted traffic or non-encrypted, right? I'm always the information, basically the headers which I'm talking about, right? Those IP addresses, the port numbers, all of that will be always non-encrypted. No one is going to encrypt the IP address. So all of those packets will anyway be non-encrypted. So I'm going to send it using NetFlow up to the Stealthwatch, and Stealthwatch can then decide, if what action it has to take, because Stealthwatch is again part of a bigger ecosystem, right? So I can integrate Stealthwatch with something like an ICE, right? We have ICE, right? And remember, we have done some videos in the past where I talked about ICE in detail, and on ICE you have something as simple as SGT, right? TrustSec. So what I can do is, as soon as I identify a particular IP address, or as soon as I identify a particular host to be infected, right? Imagine I understood that a particular host is communicating with a malicious website, so I can quickly switch the SGT of that particular host from trusted to untrusted, right? So you see now how quickly all of this played around, right? As soon as the host started talking to some malicious website in the internet, Stealthwatch came to know about it, and imagine there is a policy here, and there's an integration with ICE, and I can quickly switch the SGT to untrusted. So you can use Stealthwatch in such use cases, right? Like again, let me just reiterate this. Stealthwatch alone probably will not solve your problem, right? In a security infrastructure of an enterprise, you would obviously wanna bank on multiple different checkpoints or different defense strategy, right, at different layers, right? And Stealthwatch is one important piece in that puzzle, which looks mainly at your NetFlow, right? Mainly at your flows, mainly at your addresses, your protocol at that level, right? And I would still obviously suggest using, in addition to this, using your regular firewalls or Umbrella and WSA, ESA, and all of those other protocol products which are part of Cisco's ecosystem, right? Okay, so that being said, so I think that gave a quick background about what Stealthwatch does, and how does it play good with other Cisco's products. Again, there are a lot of Cisco Live presentations, a lot of documentation around the various integrations you can check out. But then this is one of the important things which I wanted to call out, right? The other thing is Stealthwatch is very scalable, which means I think the last time I read, you can around 600K, right? So which is 600,000 flows, right? So it can analyze Stealthwatch, a very scaled Stealthwatch system can analyze up to 600K flows per second, right? So look at this. I mean, this is really humongous, right? 600,000 simultaneous flows. It can analyze, right? It can analyze for being malicious or not, right? And it can do it per second from close to, I don't know, maybe 5,000 or 10,000 devices. So it's a huge scalable solution, right? And because in a big enterprise, you're going to have a lot of thousands of flows. Just to reiterate this, when I talk flow, what I mean is basically it's a conversation between two network devices, right? So you have probably a router and a switch, right? Whatever. So the flow is basically a conversation between two network devices, right? Maybe a large file upload, could be fragmented into multiple packets, would still kind of represent a single flow, right? But flow is basically nothing but something you represent by generally this is the standard industry definition. We say a flow is basically the one which has a source IP, right? You have a destination IP, you have a source port, destination port, and the protocol, right? So this is the 5 tuple what we call as, right? And that's basically the flow, and that is what is analyzed by your Stealthwatch, right? So yeah, so that's one of the interesting things. So again, Stealthwatch, like I said, it's you would use your firewalls, but then one of the main use case we normally tell our customers, to use Stealthwatch is when you want to especially look at that traffic which has already bypassed your firewall, right? Because maybe a firewall did not pick something, maybe it was encrypted traffic. So in such cases, Stealthwatch really plays a very important point. And now let's talk a little bit about the components, because we'll be trying some of these components in our lab, right? So I want to just give a quick glimpse of what are the various. Probably will not try out all the components because it's a heavy, building labs with Stealthwatch is very heavy because each of the nodes are super heavy. You need a lot of RAM and a lot of memory space. So okay, let's do the first one. I would say is a Stealthwatch management console, right? We say SMC, Stealthwatch management console. This is kind of like the heart of the system, right? The whole heart of the Stealthwatch ecosystem. It's literally a management console, right? You can either use a web GUI, which we will check out later, or you can also use some kind of a Java GUI, Java client as well. But nevertheless, this is the place where you can do all your configuration. You manage your other Stealthwatch devices, right? And the anomalies are reported on this particular dashboard. Alerts are seen here, right? You can also run some kind of reports, right, on the management console. You can create some policies, right? So you can create some policies to make sure that let's say there are no rogue DHCP servers in your network and stuff like that. So that's your SMC, and it is available in different form factors. We will be using obviously the virtual form factor in our labs, but I believe you also will find hardware form factors as well, right? The second one is your flow collector, right? So let's say Stealthwatch flow collector, right? SFC, or just say FC, flow collector, right? So flow collector is basically nothing but it mainly collects all your packets. You would have enabled NetFlow on your devices, right? Say a router, you would have enabled NetFlow on a router, and you can now export this particular NetFlow information to the flow collector, right? The flow collector will then talk to, or basically send that information up to it will do the analysis and then send the information up to the SMC, where you can see all your alerts and all your anomalies and stuff like that, right? So flow collector is, again, you will find it in different form factors, virtual and hardware as well, physical, right? Next, there are two other components which probably will not be doing in the lab as such. Will not be checking them out, but the other I would still call them out here. One is what we call as the flow sensor, right? So flow sensor, I'll actually show you a diagram. I'll probably write down a diagram to show how all of these pieces plays a role. But flow sensor you generally use when think of it this way, right? You basically use it if you wanna collect the flows from layer 2, right? If you want to analyze some layer 2 flows, right, then you would probably use flow sensors. Mainly you use flow sensors again if your devices don't have the NetFlow capability, right? So if you don't have your NetFlow capability, then what you can do is think of it this way. So you have a device, right, you have a port. On that port you can connect this flow sensor, right, and you can say inline. So let's say this is your device, say probably a third-party switch, right? This is a third-party switch, and say there is a host connected here, there is another host connected here, H1, H2, right? And let's say these both are communicating left and right. So what I can do now is I can configure probably span on this, span, right? So you can configure span on this particular switch, and I can probably send a copy of the packet on this particular port. Now flow sensor, what it will do is it will obviously pick think of it as it will manufacture NetFlow, right? What we are doing is, because this switch doesn't have NetFlow capability, we are sending the copy of data which is actually flowing around between these two hosts to this flow sensor, and this flow sensor can then obviously create the required NetFlow stream, right? And then it can send it up to the flow collector over here, right? So that's the reason of using your flow sensor. And the last one is the UDP director. It's one of my favorite as well. I really like UDP director, and we do always recommend customers to go with this particular appliance, right, or this particular component of Stealthwatch. It might seem little redundant at first, but it's actually very useful, right? And it's very much useful mainly for aggregating the flows, right? So let me actually draw an example here to explain what it actually does. Okay, give me a second. Right, so for flow director, in fact, let me draw a diagram and probably explain everything along with that. So you have say you have your edge router here. You can have an edge firewall, whatever it is, right? I'm gonna say this is your edge router, right, and it is connected to the internet, right? Obviously, in your case, probably you might have a firewall, right? Doesn't matter. Edge, I'm just representing it by a router. It could be firewall as well. Probably this is again internally connected to some kind of a switch, right? And probably there is one more router here, or maybe there's some other kind of a device, whatever, right? This is your, imagine this is your network, this part of it. And probably let's assume there is a management switch here, right? And on this guy, you have configured all your various, Stealthwatch related stuff, which is, you have configured your SMC, right? Imagine your, let me use this one. So this is your SMC. You have configured your flow collector here. And what else? You probably have, apart from this, you probably might have some other services, right? Like syslog. You might have things like your SolarWinds, right? So you might have like that different services running on this management switch, right? Now, I already spoke about flow sensor. So flow sensor probably would be somewhere, here, down in your network, right? Somewhere over here, right? Connected to a switch or something like that, and it would be sending traffic directly to your flow collector, which will then talk to your SMC. So flow sensor, I think, is pretty much clear. It is mainly used when your devices don't have like a NetFlow capability, and you want to kind of simulate the NetFlow capability from your devices, and it can talk to the flow collector and kind of send the flows to the flow collector. But UDP director, so that's where we were talking. So UDP director, now imagine in such a scenario, imagine you want to export the NetFlow from all the three guys, right? Imagine you have 1, 2, and 3. So you have routers, switch, probably you have R1 switch and edge router. So you want to export NetFlow from all these three guys. Now, how would you do it normally? So I would probably, send a copy of this, not just NetFlow. I mean, I would probably want to send some syslogs as well. In a normal network, you send syslogs, you send, some kind of NetFlow and all of that, right? So what would I do in such a scenario is that I would probably, from this router, I would send one copy here, one copy here. I would send one copy to the flow collector, right? So three copies. So similarly from here, 1, 2, 3, right? And 3 from here. So you'd probably have like 9 streams, right? Now this is really not good, because you would end up choking your network if you're sending so much, management data, management traffic on your network, and there won't be enough space for your actual data traffic, right? So UDP director plays a very important role. What you can do is you can configure a device to be a UDP director. It's a appliance again. Again, I think, I'm not sure if you have a hardware form factor, but I'm pretty sure we have a software form factor. And what you can do now is you can, instead of having those 9 flows, you can basically configure this guy this way, right? So all the 3 guys, you can configure only one single stream to the UDP director, right? And the UDP director will then take the job, or will then talk to the SolarWinds syslog, or probably in your case SMC or a full log collector, whatever it is, right? So this kind of drastically reduces, because your flow UDP director generally will be there where in your data center, right? So that way you don't choke your actual network with like multiple streams and multiple collection streams. So that's the use of the UDP director. So I think that's pretty much, I think that's a little bit clear now, right, with respect to the various components, right? Again, I said the last two components, or the third and the fourth one, they are kind of like, think of it as luxury components. I mean, they are not mandatory. You don't have to like use them. So these both are mandatory, right? For a Stealthwatch system, you really need to have a Stealthwatch management console, and you need to have a flow collector, right? In its simplest term, this is how it operates, right? So you'll probably think of it as a router, the router which I was talking earlier, right? You have the internet here. So probably, I can send a flow of NetFlow up to the flow collector. I can configure appliance to be flow collector, and that flow collector will then talk to my SMC, right? And then the SMC is where, the user, like a network administrator, will watch what is happening, right? And you'll be basically getting flows from multiple devices in the network, right? You'll be probing the network at different places, sending the data to flow collector. Flow collector will send it to SMC, and on SMC, we will see all the analytics, all the cool gadgets, all the cool dashboards to figure out what is happening in our network. That's the most simplest implementation of Stealthwatch, right? So that being said, I think probably I'll not spend much time on NetFlow as such. I know NetFlow is a very important protocol for our Stealthwatch system, but I think you can just read up a lot on the internet as well on it. It's a standard protocol, right? Generally, you have three important components, I believe. 1, 2, 3. What are the three? NetFlow, you have exporter, you have a collector, and the last one is your some kind of analysis software, right? So the exporter, generally what it does is it basically goes and tells NetFlow what kind of packets to match against, right, and what data to collect. So that is mainly mentioned in your that's basically what is configured in your exporter, right? And then you have the collector. Collector is basically like think of it as again an appliance or a hardware or software appliance which will collect these net flows from different parts of the network. And the last part is your analysis. So these three components are industry standard terms, right? Exporter, collector, and the analysis software. Now, how would you configure it? Obviously, you have to configure your network devices to export NetFlow, right? So there are different steps in configuring, so probably I'll show that later. In our traditional Stealthwatch system, this guy, the collector, the role of the collector is played by the flow, this guy, right over here, flow collector, right, the Stealthwatch flow collector. And the analysis software is nothing but, think of it as SMC, this one. So if I have to match these components with the Stealthwatch system, that's what. And this is going to be obviously your switch or router, and I think you even have any connect module which can send the flows from your client also, right? I think it's something new which I have not personally tested, but you can do that. You don't have to export data only from network devices. You can also get it from clients, right? So that's mainly. I'll stop with my theory now. I think it's time to check out the cool lab or the GUI and all of that and explore a little bit over there. So let's probably do that. Let me just grab my lab, one sec. Alright, so now to install Stealthwatch on your EVE-NG, it's pretty simple, right? So you go down to the how to pages on your EVE and you will find the detailed process. You obviously need to download the ISO files from your CCO page, right? You take the ISO file, you're gonna drop it in you create a directory, right, inside your QEMU folder. You drop it inside that, right, and you create a QCO2 or a KVM KVM virtual machine, right, out of that. So you create a QCO2 over here and then fix the permissions and you boot up, right? It's just like they mentioned here, it's a pretty heavy node. You'll probably want to give a little more of RAM, like 8 GB, 16 GB with some huge amount of hard disk because at the end of the day, it's storing all this NetFlow logs, right? So it should really have the required amount of memory and required amount of RAM for it to function properly, right? So what I've done is I have done till here, right, which is basically I've put the node. So once you do this one, you will be able to go to your lab. Let's go to my lab. So you'll be able to go to your lab and you'll be able to add, like for example, let's see, go to Stealthwatch and you should see Stealthwatch here, and you should be able to select either you want to have a Stealthwatch management console, flow collector. I can even put the other two devices, which is UDP detector and the flow sensor. I am really not using it in this lab, so I have not put it inside my Eve, but you can actually emulate all the 4 devices, right? So anyway, so this is how you can add a device. Make sure to connect it via VNC. So once you connect it to the VNC, you see I have 2 fresh out of the box you have 2 fresh out of the box Stealthwatch management console and your grab that. Give me a second. Yeah, here, there you go. It's on the other screen. Okay, I think this looks good. So you have you basically end up getting these 2. This is how you end up getting once it boots up. So now let's go and do some very bootstrap configuration, right? So let's start with probably my flow collector, right? Or maybe if I flow, I can do either of them. Probably SMC is also fine. Let's do SMC first. So what we do is, the first thing is you go and log in using the default username password, which is sysadmin, right? And let me just write down the password is LAN1COPE, right? There you go. So let me just write that down so that you guys also know about it. So the default username is sysadmin, right? And the password is LAN1COPE, right? So LAN1COPE, I believe it was the company which actually built this, and then Cisco acquired it in the recent years. So this is the username, and that's the password, right? And similarly for your GUI, the password is the username is admin, and the password is LAN411COPE, right? Interesting passwords, right? Just it's just a default password. Anyway, so once you put that, you basically get the screen, and this is where you do your basic configuration. So let's do that. So it's gonna ask you for the IP addresses, right? What IP address you want. So if it's my SMC, I want to put 192.168.1.2. The network mask is fine. Let me also go and put in the 192.168.gateways 1.1, which is my CSR router in my topology. The other part is I will have to also put in 192. This is kind of like the broadcast address, 192.168.1.255. Not sure why it uses that, but yeah, you have to give that. And in my case, let's use my host name as SMC, right? And obviously you want a domain, so in my case the domain is bitsplease.com. Okay, that looks good. So in my case, if you see I have a DHCP server setup as well. I think it's somewhere here. There you go. It's a DHCP server with like SMC, SFC, and one of the hosts, DNS entries being entered over that. That's it. So once I do that, I can press enter, yes, and what it will do is it will process these changes and it will reboot, right? Meanwhile, let's go and do the SFC as well. Very much the same. So let's go to sysadmin and let's use the password LAN1COPE. There you go. Same thing came here. So we can go and hit enter, and this is where we'll go and configure the IPs. So we'll put 192.168.1.3 here. That's my flow collector, and you can see on the left hand side, I think the guy is starting to reboot probably. 192.168.1. Okay, so it's gonna ask me for the reboot, so I'll have to press the enter and see, now it is rebooting. Anyway, so let's come back here. Gateway is 1.1. The broadcast IP is 192.168.1.255, and the host name I will probably use something like SFC over here, right? The domain gonna be same thing. So maybe bitsplease.com. Okay, looks good. So let's go and install this. So it'll take some time for both of them to come up successfully. So I'm going to pause the video and let's continue once both of them, come up successfully. All right, looks like it's completed. So you can see the screens now. The host name should have changed to SMC and SFC, what we have defined. You can go back to the browser now, and you can hit those two IPs, which is 1.2 and 1.3, right? And you basically get this, right? So time to use the appliance setup tool, right, to basically configure some very basic stuff, right? So what we did earlier was we configured only the IP address and the default gateway, but there might be other stuff which we need to configure. So this is where we use what we call as the appliance setup tool, right? Cool. So what we'll do is we have to do this for both the appliances. So let's do that. Probably do the SMC first. Let's go to SMC, admin, and remember the password which I wrote here, which is LAN 411 scope, right? So I'm going to use that. There you go. I'm going to log in. Okay, there you go. It's trying to log me in. Might be a bit slow because, like I said, these are very heavy systems, right? But it looks good. So what we do is next. So this is the page which it drops you, right? It's called the appliance setup tool. So let's say continue and let's configure it. So step number 1, I believe it's going to tell me to change the password, right? Because we have the default passwords. So we'll have to change that. Remember, for admin, the password is, current password is what? It is LAN1 COP. So for both for sysadmin and, for admin it is LAN 411 COP, right? So let's do that. That's the current password. I'm going to change this to something which I can remember. Right, so I'm going to say next. For root as well we need to change, but for root is going to be same as what we have for sysadmin, right? So it's going to be LAN1 COP, and I'm going to change the password to something different. Same thing for your sysadmin as well. Let's do that. Okay, that looks good. Say next. So on the left hand side you can see, right, these are the stuff which we'll be configuring. Passwords, we have to configure the network interface. Now network interface we don't have to do it because, like I said, we did it, using the console earlier, right? So if you want to change, you can change, but then I believe you change something, you'll have to reboot the system, right? So anyway, so if you want to put IPv6, you can do that as well. We don't want IPv6. So all of the rest of the stuff looks good. Let's do next, which is my host name is also, everything is there here. Probably Stealthwatch basically wants a domain, right? And you can use one Stealthwatch like per domain. So you'll have to use, in my case, I'm going to say my domain is bits please, right? So let's do that next. And the next one is, I think, the DNS server, right? DNS server, let's add an entry, and we're going to say 192.168.1.1.100, I believe. That's my DNS server, right? That looks good. Let's go next. So for NTP, it's gonna, this is the NTP server. I'm gonna remove these both. I don't want them. And my NTP server is my default gateway itself. So 192.168.1.1. Right, and it's going to ask you just to confirm if everything is good. I'm going to say yes and restart and proceed. So now it's going to restart with these updated changes. So similarly, let's go and do the exact same thing on my flow collector as well, right? So it's 411 COP, right? Exact same thing. So you don't have, there's nothing different. So I'm going to quickly go through this. While you can see the first appliance should be rebooting now, we should see on the left hand side here, it's rebooting with the updated changes, which is good. Alright, so the passwords here, let's do the same thing. you can kind of fast forward it if you have seen the earlier one, right? It's pretty much the same. Next, let's do the root. And the last one being sysadmin. Okay, looks good. So let's see if the, okay, so you can see the system is coming up. SMC is coming back up, which is good. Meanwhile, let's go back and see the next part, which is, this is fine. My host name looks good. DNS server is needed here, so I'm gonna say, yeah, this one. I'm gonna say next. This is not needed, so I'm gonna remove these two NTP servers, and here I'm gonna put 192.168.1.1, and yeah, this is also going to restart now. There you go. Right, so I'm gonna stop the video here, and when we come back in the next video, we will pick it up from here. Right, so thanks a lot, guys.